Configure and verify EBGP between directly connected neighbors. Let's talk a bit about BGP. Let's try to do it fast. Remember that BGP is a standard defined in publicly available RFCs. You will need an autonomous system number in order to work with BGP. That will depend on what do you want to use BGP for. If you are an ISP, for instance, you will need to purchase your own public autonomous system number. If you want to run the BGP only within your company for private usage, you can use a private autonomous system number. So you can use this range of private autonomous system numbers if you want to use the BGP internally. BGP offers you a set of attributes that will let you do or work with your prefix in several ways. Normal protocols like EIGRP or OSPF will only offer you the metric and maybe a tag, but BGP will offers you the next hop, origin, ASPAT, local preference, atomic aggregate, aggregator ID, community, MET, originator ID, and cluster ID attributes in order to do several things with your prefixes, such as influencing how your traffic goes out of your autonomous system, or maybe influence how the traffic that will enter your autonomous system will happen. So when establishing a connection, BGP uses TCP. So as any TCP connection, one device will use a random port above 1024 and will connect to the other device using the BGP port number, which is 179. BGP routers will need a router ID, which is 32 bits, and it is expressed as an IPv4 address. It must be unique. The router ID 0.0.0.0 is invalid. The best practice is that you must configure it manually, otherwise your operating system will choose one for you. Notice that for iOS, the highest IP address is chosen, whereas in other operating systems, the lowest IP address is used. So be aware of that. Changing the router ID will reset your sessions, and in order to for two devices to become neighbors, they must validate that the source IP and the autonomous system exists in the configuration, and the router's IDs must be unique, must be valid, and must be different. So you have 4 packets in BGP: the open, which is used for negotiation and validation; the notification, that is used to send errors if one device receives a notification message and the BGP session is turned down. The keep alive is like a hello, and the update is used to advertise or withdraw routes. The timers for the keep alive by default is 60 seconds, which is the hello, and the hold time is 180 seconds. However, you can reduce the hold time, and when two devices negotiate the connection, they will choose the lower hold time. If the hold time happens to be 0, you might end up having a keep alive of 0 seconds. You can reset sessions in 2 ways. The hard reset will kill the TCP session and will take longer to come up. Again, the soft reset will not tear down the TCP session. That means that it will happen faster. There are several BGP states. If everything happens correctly, you will start with the idle, then you will go to connect, where a 3-way handshake is tried. If this is successful, an open message is sent, then we move to open send. In the open send state, we wait for an open from the other side, then an evaluation is run. If everything is successful, a keep alive is sent, and we move to open confirm. In the open confirm, we wait for a keep alive from the other side. If a keep alive is received, we go into established state where we can exchange routes. So if two routers become peers and they belong to the same autonomous system, they are said to be running an EBGP peer. It is advised that you run EBGP within your autonomous system, opposite to running other protocols like OSPF and ERGRP, and then redistribute between protocols. Because if you run BGP on all your autonomous system, you will support a great amount of routes. OSPF and ERGRP cannot support as many routes as BGP can. You can keep your attributes, and you can still use the best path selection algorithm. And EBGP peers will follow a set of rules that are not the objective of the ENCORE exam. Now, what happens if two devices peer and both devices live in different autonomous systems? Then those devices are said to have an EBGP peering. By default, for EBGP, the TTL is set to 1. That means that devices must be connected back to back. Otherwise, you will have to configure it in order to have a multi-hop sessions. These have a downside because all transit routers in multi-hop sessions will must know all the routes, because maybe you can establish your BGP session, but the routing will not work unless this happens. So for outgoing advertisers, EBGP will set themselves as the next hub for all routes, and it will append their autonomous system number to the S path. So on EBGP peering, that will happen for advertised routes. If you are summarizing or aggregating as BGP names it, the S path will get deleted, and only the autonomous system number of the device that is summarizing will exist in the S path, or you can enable the usage of a set. Now, for incoming advertisement, the S path is checked to as an anti-loop mechanism. So when you receive routes from an EBGP peer, you will check the attributes. If your autonomous system exists within the S path of any prefixes, that prefix will be dropped. So how do you add routes into BGP? You can use the network command, where the routes are identified as I or internal. BGP, in order for this to happen, BGP will have to validate if this prefix you're using with the network command exists in the routing table. If this prefix does not exist in the routing table, it will not import this network into the BGP RIP, that is known as local RIP. For connected routes, dedicate assign an X hub of 0.0.0.0. That happens with any protocol. And you can also inject routes using redistribution, where routes are identified as a question mark. You can have BGP communities, which are 32-bit wide numbers that can be expressed as a single large number or as two 16-bit numbers, which is known as the new format. For iOS, if you want to use the new format, you have to execute this command, IPBGP community in format. But in other operating system by CISCO, this is a default, so you don't have to enter it. It is recommended that if you're going to use communities, the first 16 bits are the same as your autonomous system number. You should be aware that there are reserved communities that are known as well-known communities that all start with hexadecimal. So don't use any of that, any community in that range. some operating system will not set communities, so you have to execute the command send community, standard or extended. Standard is the default. Extended communities are used when you are using multi-protocol BGP. Specifically, iOS XR will only send community to IBG peers by default. But for EBGP, you have to execute this particular command, send community EBGP, or send extended community EBGP. Remember that when using route maps, always consider using the additive parameter. If you don't use the additive parameter, you will override all the communities that belong to the prefixes. There is something that is known as multi-protocol BGP, which is an extension of BGP. This extension will let you use address families. In order to use that, these fields are used in the BGP advertisements, which is the AFI and SAFI. AFI will tell you the address family, 1 for IPv4, 2 for IPv6, whereas the SAFI number 1 is for unicast and 2 for multicast. So you can have many address families. You can have the IPv4 unicast family, the IPv4 multicast family, IPv6 unicast family, IPv6 multicast family, and you can have other address families such as VPN family and so on. That is used for MPLS. So the configuration changes a bit because in plain vanilla BGP you only establish the IP address of the peer and the autonomous system, but with multi-protocol BGP you have to also create an address family mode, and within the address family mode you have to enter the peer name, the peer IP address, and the activate parameter. So for iOS, this address family IPv4 gets configured automatically with the activate parameter, so you don't have to enter any other commands unless you enter the no BGP default IPv4 unicast. In that case, you will have to enter the address family and the activate parameter manually. Remember that when using IPv6 with BGP, you will have to enter your peer device global unicast address and don't use the link local address. Remember that other IPv6 aware protocols like using link local addresses such as OSPF version 3 likes using link local addresses, but BGP recommends using global unicast IPv6 addresses. When doing summarization, you can create a static summarization. This will involve creating a static node route. This summarization always gets advertised, or you can use a dynamic summarization known as aggregation that will only happen when receiving a prefix that belongs to that aggregation. The aggregated prefixes will get these parameter added, atomic aggregate, so other devices will know this prefix comes from an aggregation, and you can also enable AS set. Remember that AS set is an unordered list of autonomous system numbers. You have 3 routing tables internal to BGP. The adjacents read in where routes that are coming from peer devices are placed. The local rev, that is the routing tables that BGP will use to work, and the adjacency rev outgoing, that is the routing table where prefixes that are going to get advertised are placed. So remember that you have several RIPs with BGP. Now, the filtering topic is quite extensive. There are several ways to filter in BGP, but the basics are that you really should use filtering, especially when working with EBGP, because if you don't filter routes when using EBGP, your autonomous system might become a transit autonomous system. You don't want your autonomous system to become a transit autonomous system unless you are a tier 1 internet service provider. So if your autonomous system become a transit autonomous system, your devices and your links will be seeing traffic that is not originated by you and it is not destined to you, so you will be seeing traffic for other users and destinations that are not related to you, so you don't want that. So always filter when having EBGP sessions. You can use standard ACLs to filter. You can use the distribute list command to do so. With using a standard ACLs, you can only define a set of networks. You cannot define masks. So if you want to set or define networks and masks, you can use the extended ACLs. You can use the distribute list command. The recommended way to filter is using prefix list. So remember that when using BGP, rather use prefix list than access list. With a prefix list, you can define networks that comply with the first n bits, and then you can establish a mask range. Use the prefix list command in order to use this. And you can also filter the S-path using regular expressions. And you can also use route maps. Remember that route maps works like an ACL, where entries are evaluated top to bottom, have sequence numbers, ends with an implicit deny all. The difference with an ACL is that rather than evaluating packets or frames, with a roadmap, you are evaluating a set of BGP prefixes along with their attributes. So they are subject to evaluation to every entry within the route map. If a set of prefixes matches an entry, that set of prefixes are no longer subject to subsequent entries, just like a regular ACL, and the remaining prefixes that didn't match will continue to get subject to evaluation. Each entry in the roadmap contains a permit or deny clause that will indicate whether the matched prefixes will get advertised or not, a sequence number, one or many match statements, which indicates the conditions to get evaluated. This match can include an access list, a prefix list, a community list, or whatever. The absence of a match indicates match any. Multiple conditions in one match work as an OR. Multiple matches work as an AND. An optional set statement is used to execute an action, like modify an attribute. Optionally, you can use the statement continue, which is not recommended because that will break the rules of route maps. So matched prefixes will keep on getting evaluated. So this is the best path selection algorithm. You have to remember this order for the exam. So when BGP has several prefixes that are the same, the BGP will have to decide what is the best prefix among all. With other protocols like EIGRP or OSPF or any other protocol, the way to choose the best prefix is usually the one that has the lowest metric. And there are other things that some protocols take into account, but by no way those mechanisms are as complex as the BGP best path selection algorithm. So BGP will take into account the weight, which is a proprietary attribute for Cisco. You will not find the weight attribute in Huawei or in Aruba or in other device. Weight is only Cisco proprietary. And then BGP will look into the local preference. Then it will look into whether this path was locally originated. Then it will look into the AIGP. Then it will look into the AS path. Then into the origin type. Then into the map. Then into the path or peer type. Then it will look for the lowest next hop, all the route, lowest router ID, minimum cluster length, lowest IP address. So in order to remember this, there is a mnemonic that is pretty well known over the internet, that it is "we love oranges" as oranges mean poor refreshment, that refers to each one of the parameters that are evaluated. So this mnemonic will let you remember how this, I'm sorry, this is this one and this is this one. So you can remember this best path selection algorithm. So you can use this 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 will let you remember how the best path selection algorithm works. You will need this for the exam. So we'll check all of these in the lab.